Welcome to this explainer. Today, we're mapping out Marco Stanley Andrade's absolutely captivating architectural proposal for a next-generation mission to Saturn. If you're fascinated by the wild engineering of deep space travel and the search for extraterrestrial life, well, you're in the exact right place. We are going to break down an incredible, highly detailed concept that envisions not just returning to the ringed planet, but actually establishing a permanent robotic presence there.
Okay, let's dive into this by grounding ourselves in the sheer scale of the Saturnian system. We're talking about a gas giant over 95 times the mass of Earth, sitting roughly 1.4 billion kilometers away. But the true targets for astrobiologists aren't just the majestic rings, right? It's the tantalizing moons orbiting within them. Worlds like Titan, Mimas, and especially Enceladus, which harbors some pretty massive secrets beneath their icy crusts. We're going to follow an evolutionary journey today. Our agenda covers 1. The legacy of Cassini. 2. Why return. 3. The new architecture. 4. Landing on Mimas. And finally, 5. Submarines on Enceladus. Section 1. The legacy of Cassini, the historic ancestor. To truly understand the revolutionary upgrades proposed for Cassini 2.0, we first have to look back at the triumphs and, the ultimate limitations of its historic ancestor, the original Cassini-Huygens mission, which orbited Saturn from 2004 to 2017.
So, an absolutely crucial point to remember is the immense investment of that original mission. We're looking at a cost of nearly $4 billion, backed by decades of intense research by brilliant physicists and engineers at NASA. This massive figure highlights exactly why a sustainable survival plan is so vital for future space architectures. Sacrificing a multi-billion-dollar machine simply because it runs out of gas? That's a loss we definitely want to avoid next time around.
Now, deep space travel requires some truly unique mechanics. The original 6.8-meter-tall spacecraft relied on what's called hypergolic propellants. Because space is a vacuum, you can't just strike a match to light an engine. Instead, you use chemicals like monomethylhydrazine and nitrogen tetroxide that literally explode the instant they touch each other. This allows the spacecraft's computers to turn the engines on and off with absolute pinpoint precision.
Think about the internal plumbing for a second. You have your tanks, holding the liquid fuel, and the oxidizer. But in zero gravity, liquids don't just sit at the bottom of a tank. They just kind of float around in blobs. So how do you actually get them into the engine? Well, you use a separate tank filled with helium gas kept at extreme pressure. That helium basically pushes those floating liquid propellants down into the main engines without any dangerous air bubbles. It's honestly an incredibly elegant solution.
But here's the catch. You can't use those main engines for every little turn, or you'd run out of fuel way before the 7-year journey to Saturn was even over. So to save fuel, Cassini utilized reaction wheels. These were 15-kilogram metal discs inside the ship that spun electrically at over 2,000 RPM. By spinning these wheels, the spacecraft generated torque, allowing it to pivot and point its cameras and antennas without firing a single drop of precious chemical propellant.
However, despite its massive history-making success, the hero's journey of Cassini-1 ended in a tragic sacrifice. When the propellant finally ran low in 2017, the spacecraft just couldn't sustain a stable orbit anymore. Terrified that a dead Cassini might eventually crash into Enceladus and contaminate its pristine, life-harboring oceans with Earth microbes, engineers deliberately plunged the probe into Saturn's crushing atmosphere.
Section 2. Why return? The call to adventure. We know how the first mission ended, so what is the justification for going back? Let's see how this builds the foundation for Marco Stanley Andrade's proposed return.
The proposal asks, why go back? And answers with a bold, multi-target mission designed not just to visit, but to stay. First, we absolutely need to confirm the habitability of Enceladus. Second, we want to establish a permanent interplanetary communications hub using lasers and radio frequencies while monitoring Saturn's climate for decades. And to get there efficiently, the proposal even outlines a natural gravity assist flyby of Venus to slingshot and accelerate the craft without burning all that precious fuel.
Section 3. The new architecture. Enter Cassini 2.0. This brings us to the new hero of our explainer. This highly advanced theoretical spacecraft architecture isn't just a copy of the old probe. It is a massive, game-changing leap forward in planetary exploration technology. Cassini 2.0 would be absolutely huge, a 16-meter-tall cylindrical body. But the most striking feature is right at the top. Instead of a fixed, rigid dish antenna like the old one, Cassini 2.0 would feature a carbon ceramic pyramid. During dangerous maneuvers, this pyramid stays closed tight to protect delicate instruments from micrometeorites and ice particles. But out in open space, the sides lift up and open like a blooming flower, transforming into a massive 8-meter octagonal antenna, very similar to how the James Webb Space Telescope operates.
To survive permanently, the proposal radically upgrades the internal mechanics. Remember those old physical steering wheels we talked about? They eventually wear out due to metal-on-metal friction. Cassini 2.0 replaces them with frictionless, magnetic-bearing reaction wheels, allowing for literally decades of zero-wear steering. It also incorporates SpaceX-style electric gimbal engines for precise, autonomous landing maneuvers, multiple 4K cameras protected by glass domes with automated cleaning wipers, and next-generation nuclear batteries to power the whole shebang in the deep, dark cold of the outer solar system.
Section 4. Landing on Mimas. Securing a permanent outpost. So what happens when this incredible new machine eventually runs low on fuel? Instead of a suicidal crash landing into Saturn, Cassini 2.0 is designed to survive its fuel depletion by anchoring itself to Mimas, a dead, heavily cratered icy moon nearby.
Landing on Mimas is incredibly tricky, mostly because it has almost zero gravity and a very high orbital speed. If you just touched down normally, the spacecraft would likely bounce and ricochet right back into deep space. So what's the solution? Cassini 2.0 is equipped with three 6.5-meter landing gears with stainless steel tips shaped like tiger claws. As it touches down, these claws are superheated. They'll instantly melt into the frozen surface, and the moment the heat is cut, the surrounding water will flash freeze, literally welding the ship permanently to the moon's surface. It instantly becomes a permanent fixed observatory.
Section 5. Submarines on Enceladus. The ultimate search for life. But before retiring to Mimas to act as a permanent watchtower, the spacecraft must deliver its absolute most ambitious payload to Enceladus. This is the moon where the first Cassini discovered geysers of salty ocean water shooting out into space, proving there's a massive subsurface ocean down there.
The lander drop over Enceladus reads like a cinematic sci-fi sequence. The main ship performs a flyby of the chaotic South Pole and detaches the lander. An onboard autonomous AI immediately takes over, firing its gimbal engines to navigate the violent, chaotic liquid water plumes shooting up from the surface. The lander hits the ground at a calculated high speed. Its nose is a superheated steel cone that uses immense thermal energy to melt straight down through the thick icy crust, plunging toward that hidden ocean below.
Once it breaches that hidden ocean, the magic really happens. The lander opens up and releases a school of 50-centimeter robotic submarines, essentially AI-controlled robotic fish. Equipped with non-radioactive batteries, lasers, and radio frequency data links, they will autonomously map the dark abyss, hunting for thermal vents and signs of life. And of course, the proposal heavily stresses that all of this requires extreme, unprecedented sterilization protocols back on Earth before launch, just to ensure we explore this alien ecosystem without accidentally destroying it. As we wrap up this explainer, we are left to wonder, if an architecture like Cassini 2.0 moves from a theoretical proposal to a fully funded reality, what profound secrets of life might those robotic eyes finally reveal in the dark, alien waters of Enceladus? Are we truly alone, or is the dark ocean of Saturn's tiny moon just teeming with alien fish waiting for us to break through the ice? Thanks so much for joining me today, and keep looking up.